Hey everyone, I hope you're doing well. In this lesson, I'm going to be covering systems of equations, specifically linear systems that have two variables. I'll begin by solving 4 linear systems using the substitution method, then 4 problems using the elimination method, and finish up the video solving 2 application word problems. Let's get into it. Here we have 4 linear systems that we can solve using the substitution method. The reason why we use the substitution method for these types of linear systems is because they already have an isolated variable. Notice how in each of these examples, they all have an isolated variable, whether it's x or y. When you see an isolated variable to begin with, substitution is always a good method. I'm going to begin this problem by just copying it down. And what I notice right away is that they both have y isolated. It's important to remember that when solving linear systems, the y value in the first equation has to match the y value in the second equation. The same goes for x. Since y is equal to 3x plus 2, and this y in the second equation is the same as the top y, we can substitute these two expressions for each other. Once we make this substitution or swap, we're going to get 3x plus 2 is equal to 7x minus 6. Now that we just have one variable, we can solve for x. Now our goal is to get all the x terms to one side and all the constant terms to the other. I'll start off by subtracting 7x from the right side and 7x from the left side. 3x minus 7x is going to be negative 4x, we still have a plus 2, 7x minus 7x is 0, and we have negative 6 on the right side. Next, I'm going to subtract 2 on the left side and subtract 2 on the right side, and I'll be left with negative 4x. The 2's cancel out, and we're left with negative 6 minus 2, which is negative 8. To get a coefficient of 1, we're going to divide the left side by negative 4 and divide the right side by negative 4. Since negative 4 divided by negative 4 is 1, we can just write 1x or just x, and negative 8 divided by negative 4 is positive 2. Well, we found out that x is equal to 2, that's just part of our answer. To solve for y, we're going to take this value of x equals 2 and either plug it into this top equation here, or plug it into this bottom equation here. Plugging x into either equation will get us the value for y. In this problem, my preference is to plug it into the top equation, so I'm going to write y is equal to 3 times, and I'm going to substitute 2 in for x, and write plus 2. And 3 times 2 is going to be 6 plus 2, and then we know y is then going to equal 8. And now we also know the value for y. When writing the solution to this system, we write it as an ordered pair of 2, 8. Looking at the graphs of these two linear equations, we can see that they intersect at the point 2, 8. In the second equation, we have y is equal to x plus 2, and we have x is equal to negative 3. Since the second equation already tells us that x is equal to negative 3, we already have half of our answer. Since x is equal to negative 3, we're going to substitute it in for the x in the top equation. Once we substitute, we're going to get the equation y is equal to negative 3 plus 2. When we add negative 3 plus 2, we're going to get negative 1. So while we had to solve for y to find out it was negative 1, we already knew that x was equal to negative 3. The solution to this system is negative 3, negative 1. Looking at this graph, we can see that the two equations do meet at negative 3, negative 1. In this next one, we have y is equal to negative 5, and we have 5x plus 4y is equal to negative 20. Since y is already alone or isolated, we can make a substitution for it. Once we substitute, we're going to get 5x plus 4 times negative 5, because that's what y is equal to negative 20. Since 4 times negative 5 is negative 20, we can simplify this equation to 5x minus 20 is equal to negative 20. To solve for x, we're going to add 20 to both sides. And doing so, we're going to get 5x is equal to 0, since negative 20 plus 20 is 0. Finally, we're going to divide both sides by 5, and we're going to get that x is equal to 0. While we had to find out x equals 0, we already knew that y equals negative 5. The solution here is going to be 0, negative 5. Here we can see that the graph does confirm our solution. In this next one, we have x plus 7y is equal to 0, and we have 2x minus 8y is equal to 22. While none of the variables are isolated from the start, isolating this x can be done easily. I'm just going to rewrite this top equation on the side so that we can solve for x. To get x alone, I'm going to subtract 7y from the left side and subtract 7y from the right side. In doing so, we're going to get that x is equal to negative 7y. Now that we know that x is equal to negative 7y, we can substitute it in for this x here. When making that substitution, we're going to get 2 times negative 7y, because that's now x, minus 8y equals 22. 2 times negative 7y is going to be negative 14y, minus 8y is equal to 22. Negative 14y minus 8y is going to be negative 22y, and that's equal to 22. And we can solve for y by dividing the left side by negative 22 and dividing the right side by negative 22. When we do that, we find out that y is equal to -1. To solve for x, we're going to substitute y equals -1 in for y here. Since the top equation is a little simpler, I'm going to plug in y is equal to -1 to solve for x. Once we substitute, we're going to get x plus 7 times -1 is equal to 0. 7 times -1 is -7, so we're going to get x minus 7 is equal to 0. And we're going to add 7 to both sides here to find out that x is equal to 7. Now that we have both x and y, we can say our solution is 7, -1. And here we can see that our graph checks out. If a variable isn't easily isolated, elimination is going to be a better choice. In this first one, we have 2x plus y is equal to 5, and then we have 3x minus y is equal to 5. When we complete the elimination method, our goal here is to eliminate one of the variables, either x or y. To eliminate the x terms, we're going to have to find the LCM of 2x and 3x, which is actually going to be 6x. If we wanted to eliminate the y terms, we have to find the LCM of them, and that's just going to be 1y. While you could eliminate either one, eliminating y is going to be easier since their coefficients are already 1. Since this positive y and negative y are opposites, we're going to add them to eliminate them. When we add these two equations together, 2x plus 3x is going to get us 5x, y plus -y is going to be 0y, so it gets eliminated, and 5 plus 5 is going to equal 10. We're going to divide the left side by 5 and divide the right side by 5. 5 divided by 5 is 1, which is just 1x, and 10 divided by 5 is going to equal 2. Since y was eliminated, we were able to solve for x, which is 2. Now that we know what x is, we can plug it into one of the equations to solve for y. I'm going to plug it into this top one here. When we substitute, we get 2 times 2 plus y is equal to 5. 2 times 2 is 4, so we're going to write 4 plus y is equal to 5. We're going to subtract 4 on the left side, subtract 4 on the right side. 4 minus 4 is going to be 0 on the left, so we're just going to get y is equal to, and 5 minus 4 is equal to 1. So here our solution is going to be 2, 1. Here's the graph to confirm our answer. In this next one, we have 5x plus 4y is equal to 22, and we have 7x plus 6y is equal to 32. The LCM for 5x and 7x would be 35x, while the LCM for 4y and 6y is going to be 12y. Between these two, I'm going to choose to eliminate the y's since we have to multiply by smaller numbers. To get the top equation to have 12y, we're going to have to multiply the whole thing by 3. To get the whole bottom equation to have 12y, we're going to multiply the whole thing by 2. Our equivalent equations are going to be 15x plus 12y is equal to 66, and 14x plus 12y is going to equal 64. Since they both have 12y, we can subtract these two equations to eliminate the y's. When subtracting these two equations, 15x minus 14x is just going to be 1x, or x, 12y minus 12y is going to be 0y, so they get eliminated, and 66 minus 64 is going to equal 2. Now we're halfway there. To solve for y, I'm going to substitute x equals 2 into the top equation. When we substitute, we get 5 times 2 plus 4y is equal to 22. 5 times 2 is 10, so we're going to get 10 plus 4y is equal to 22. We'll subtract 10 from both sides. 10 minus 10 is 0, so we can say 4y is equal to 12, since 22 minus 10 is 12. And we're going to divide both sides by 4, and we can say y is finally equal to 3. Our solution here is just going to be 2, 3. Here we can see the graph checks out. In this next one, we have negative 9x plus 5y is equal to negative 4x, and we have negative 11x is equal to negative 20 plus 9y. From the beginning, we want to notice that these two equations aren't organized the same way. Let's reorganize the top equation in standard form. So negative 9x plus 5y is equal to negative 4x. We can add 4x to the right side and add 4x to the left side. From that, we can see that negative 9x plus 4x is going to be negative 5x. We still have plus 5y, and now it's going to equal 0. This version will be easier to use. Now let's rearrange the second equation so it also matches in standard form. So negative 11x is equal to negative 20 plus 9y. We can subtract 9y from the right side and subtract 9y from the left side. Now the second equation is also in standard form. Now we can use elimination to solve this system. In this problem, I'm deciding that I want to eliminate the x's. I'm going to multiply the top equation by 11 to do so. Then I'm going to multiply the entire bottom equation by 5. 11 times negative 5 is going to be negative 55x. 11 times 5y is going to be positive 55y. And 11 times 0 is just going to be 0. Underneath, 5 times negative 11x is going to be negative 55x. 5 times negative 9y is going to be negative 45y. And 5 times negative 20 is going to be negative 100. Notice how I just got the 55s to match. To eliminate the x's, we're going to need to subtract these two equations to get 0. Negative 55x minus negative 55x gets a 0x, so it gets eliminated. 55y minus negative 45y is going to be a positive 100y, and 0 minus negative 100 is going to be positive 100. When dividing both sides by 100 here, we find out that y is equal to 1. Notice how by multiplying both equations by 11 and 5, we were able to get matching coefficients to eliminate the x. Now that we know that y is equal to 1, we can substitute it in to solve for x. Once we substitute, we see that negative 11x is equal to negative 20 plus 9 times 1. Since 9 times 1 is just 9, we're going to get negative 11x is equal to negative 20 plus 9. Negative 20 plus 9 is just going to be negative 11, and we can divide both sides by negative 11 to find out that x is also equal to 1. After all that work, the answer here is just 1, 1. Here we can see that the graph backs our answer up. In this next one, we have 4x plus 2y is equal to 14, and we have 3x minus 5y is equal to negative 22. This one's a little nicer than the last one since they're both in standard form. In this problem, I'm going to eliminate the y's by making them both have a 10y. To get this, we're going to have to multiply the whole top equation by 5 and multiply the whole bottom equation by 2. 5 times 4x is going to be 20x, 5 times 2y is going to be 10y, and 5 times 14 is going to be 70. Underneath, 2 times 3x is going to be 6x, 2 times negative 5y is going to be negative 10y, and 2 times negative 22 is going to be negative 44. Now that the y's have matching coefficients, we can add these two equations to eliminate the y's. So 20x plus 6x is going to be 26x, 10y plus a negative 10y gets a 0y, so it gets eliminated, and 70 plus negative 44 is going to be 26. Dividing both sides by 26 here, we're going to find out that x is equal to 1. Let's substitute 1 into the top equation to solve for y. 4 times 1 plus 2y is going to equal 14. 4 times 1 is 4, so we have 4 plus the 2y, and that's equal to 14. We can subtract 4 from the left side and subtract 4 from the right. 4 minus 4 is 0, so we get 2y is equal to 14 minus 4 is going to be 10. We divide the left by 2 and divide the right by 2, so we found out here that y is equal to 5. Our solution here is going to be 1, 5. Here we can see a graph that confirms our answer. Here, Evie and Claire each separately go to Chipotle to pick up some food for their families. Evie picks up 6 burritos and 5 tacos, which cost $69.75, while Claire picks up 2 burritos and 16 tacos for $77. How much did each burrito and each taco cost? I'm going to start by defining my variables. B is going to represent the cost of a burrito, and T is going to represent the cost of a taco. Let's write 2 separate equations, one for Evie and one for Claire. Let's write down what we know about Evie's situation. We know that she bought 6 burritos and 5 tacos for a total cost of $69.75. What about Claire? Claire picked up 2 burritos and 16 tacos for a total of $77. It's important to know that 6B and 2B represent the total cost of the burritos, 5T and 16T represent the total cost of the tacos, and $69.75 and $77 both represent the total cost of each of their orders. I'm going to use elimination to solve this system. I think it makes sense to eliminate the b's here because we can just multiply the bottom equation by 3 to get 6, which is the LCM for 2 and 6. While Evie's equation is going to stay the same as 6b plus 5t is equal to 69.75, Claire's new equation is going to be 6b plus 48t is equal to 231. Now that the coefficients for the b's match, we can subtract them to eliminate the b's. When we subtract these two equations together, 6b minus 6b gets eliminated, 5t minus 48t is negative 43t, and 69.75 minus 231 is negative 161.25. To find the price of one taco, we're going to divide the left side by negative 43 and divide the right side by negative 43. Negative 161.25 divided by negative 43 is going to be 3.75. So the cost of one taco is $3.75. Let's substitute this value in to find the cost of a burrito. When we substitute, we're going to get 6b plus 5 times $3.75 is equal to $69.75. 5 times 3.75 is going to be $18.75, so we have 6b plus $18.75 is equal to $69.75. Let's subtract $18.75 from the left side and subtract $18.75 from the right side. When we do that, we find out that 6 burritos are going to cost $51. To find out the cost of one burrito, we can divide both sides by 6, and we can say that one burrito is going to cost $8.50. Assuming that Evie and Claire went to the same Chipotle, one burrito is going to cost $8.50 and one taco is going to cost $3.75. And let's try one last one here. In this problem, Zach and Marty are both competitive runners. One week, Zach runs 4 miles and Marty runs 8 miles, but together they ran for a total of 80 minutes. Another week, Zach runs 9 miles and Marty runs 6 miles for a total of 105 minutes. What's the average pace each of them are running for? First, I'm going to define Z as being Zach's pace. Then I'm going to define M as Marty's pace. Let's write an equation to represent what they ran in week 1. We know Zach ran 4 miles at some given pace, and we know that Marty ran 8 miles at another given pace. Adding their times up together, we know they ran for 80 minutes. Now let's write an equation for the other week. We'll call it week 2. In week 2, we know that Zach runs 9 miles at his average pace, and Marty runs 6 miles at his average pace, for a total of 105 minutes. Remember, the 4Z and 9Z represent the total time that Zach was running, the 8M and 6M represent the total time that Marty was running, and the 80 and 105 represent the total amount of minutes that they ran together in each of the weeks. In this problem, I'm going to eliminate the M's by making them both 24M. To do that, we're going to have to multiply the top equation by 3, and then multiply the bottom equation by 4. 3 times 4Z is going to be 12Z, 3 times 8M is going to be 24M, and 3 times 80 is going to be 240. On the bottom equation, 4 times 9Z is going to be 36Z, 4 times 6M is going to be 24M, and 4 times 105 is going to be 420. Now that the coefficients for M match, we can subtract these two equations to eliminate the M. 12Z minus 36Z is going to be negative 24Z, 24M minus 24M equals 0M, so it gets eliminated, and 240 minus 420 equals negative 180. When we divide the left side by negative 24 and the right side by negative 24, we find that Z, or Zach's pace, is equal to 7.5, or 730-minute mile. Now that we have Zach's pace, we can plug it into this equation to find out Marty's pace. Substituting in, we get 9 times 7.5 plus 6M is equal to 105. 9 times 7.5 is going to be 67.5, which is 67.5 minutes, plus 6M is equal to 105 minutes. Let's subtract 67.5 from both the left side and the right side to solve for how long it takes Marty to run 6 miles. Since 105 minus 67.5 is going to be 37.5, we know it took him 37.5 minutes to run 6 miles. Dividing both sides by 6 here, we find out that M, or Marty's pace, is equal to 6.25. The Z equals 7.5 represents that Zach's average pace was 7 minutes and 30 seconds per mile, while the M equals 6.25 means that Marty's average pace was 6:15 per mile, since 0.25 is a quarter of a minute. I hope this video gave you a better understanding of how to solve linear systems. Thanks for stopping by, and keep up the good work.